Thou shalt not covet thy neighbor's paper, nor anything that is thy neighbor's. I love math!
Hey math lovers, let's go over the Module 3 test take on April 27, 2022. Question number 1 says, how many real solutions does the equation have? Remember, real just determines if it crosses the x-axis here. You'll notice that you have two sides of the equation, so we're going to move everything over, and I think I changed this one to a 2. So I'm going to go ahead and do the opposite to move it over. So 0, 0. You have x to the third minus 2x squared plus x minus 2. Okay, here I have 4 terms. I'm going to try to factor here by grouping. And I'll show you guys my method of factoring by grouping or just using this box method. So we're going to go in like a z. And over here, the greatest common factor is x squared. This direction is x, this direction is minus 2, and this one is just, if there's nothing, it's just a 1. And what you're going to have here is x minus 2, x squared plus 1. And then you're just going to set it equal to 0. This will give you x equals 2. And you're going to subtract 1, so you get negative 1. And then take square root. When you do that, you have x equals plus or minus. Remember, square root of negative 1 is I. And this is actually 2 solutions. So we have 2 complex. And we have 1 real. If you add those together, that gives you the 3 that comes from the highest degree of the polynomial. So our answer for the first one will be B. Okay, number 2 is left blank. Number 3, we can use a graphing calculator. And again, the graphing calculator you're going to have to do the same thing. So I'm going to subtract this. This one's a like term, but this one is not. So everything on this side will turn into zeros. Okay, this one will become negative 7x. This one goes away. You have x to the third and plus 4. X cubed minus 7x plus 4. X cubed minus 7x plus 3. Is that what I said? Plus 4. Right. And we're asked to solve. So solving means where it crosses the x-axis. And I have here 2.29. 0.60 and negative 2.89. And that would be choice D. Alright, question number 4. I have the graph of f of x, and that one's cubic, so that'll be this one, orange one. And then you have a linear, which is this one, pink. They are shown, use a graph to find the solutions of, and then you have this polynomial equation. You'll notice again it's on both sides, so I'm just going to move everything to one side. And what I'm doing here is just setting equal to 0. become 2, negative x, negative 2x squared, and x cubed. So I'm just going to use a different method here called factoring by grouping. We use the box in number 1, but I'm just going to focus here. My greatest common factor is x squared, and then I'm left with just x minus 2. You know, if I factor out a negative 1 in this problem, I get x minus 2. Remember, you can always distribute to get what we have here above. And the reason why I did that is because you'll notice I can now factor out a second greatest common factor, which is x minus 2. You're left with x minus 2 minus 1. Minus 1 this string. And put that in parentheses. And again, this one works because if you take the whole expression in pink here, and then you distribute here, you get this term. And take x minus 2 and distribute to the negative 1, you'll get that term. Okay? Okay, so from here, you can just set each of those equal to 0. This is called the zero product rule. And here you're going to get x equals 2. You're going to add 1 to both sides and take the square root. You'll get x equals plus or minus 1. So let's take a look at our answers here. I have 2. And I have 1 and negative 1 and positive 1. So our answers are B, C, and D. Question number 5. Find the factors of x cubed minus 3x squared plus 16x minus 48. Again, I'm going to use factoring by grouping. Hopefully I can factor something out here. And it looks like I can factor out an x squared. I'm just left with x minus 3. You can distribute to check your answer. Then over here, I'm going to try to factor out a 16. I get x minus 3. And you notice that this will work is when you have here in this parentheses the same, because you can factor that out again. So I'm just left with x squared plus 16. Let me put that in parentheses here. Okay, so if I take a look at I don't need to solve, I'm just factoring, find the factors. So in blue, that would be x squared plus 16, choice A, and x minus 3, which is choice D. Alright, question number 6. I notice I have 4 terms, but before you do that, you always want to see if you have the greatest common factor. You'll notice that each of these have an x here, so I pulled that out. And then you're left with 4 terms here in the parentheses. So I'm going to go ahead and put that in here. I'm going to use the area model. I've been alternating just so you can see different ways. I have an x squared, x, 2, and a 9. Okay, pay attention now. So I'll do it in pink, because this here becomes x squared plus 9, x plus 2, and then this is what students always forget, is that extra x right here. I'm going to set each of those equal to 0. Zero product rule. And this one's already solved. Subtract 9. Take the square root. You're going to have plus or minus. Remember, every time you take the square root of an equation, it's going to be plus or minus. Then you have the square root of negative 1 times square root of 9, which is square root of 9 is 3 and square root of negative 1 is I. So you have 2 solutions there. And then that will become x equals negative 2. So 0, that's all of those. Negative 2, which is this one, and then plus or minus 3i. So the answer would be B is your correct answer. Alright, question number 7 is use the substitution method to write 6x to the 4th plus 16x squared plus 7 in a quadratic form. And quadratic form just basically means that the highest degree should just be a power of 2. Well, how do you do that? Well, our goal is to write it like this. So I need to think of a number when I square it equals 16x to the 4th. So you can do something like this. So let's put a u here. So u squared, because I see the u's over here, equals 64x to the 4th. And if I take the square root of both sides, the square root of 64 is 8, and the square root of x to the 4th is x squared. Because the opposite of that is if you just square it, you will get what's above. So that basically means that the u is equal to 8x squared. Let me just write that out so you can see this. If I put an 8x squared here, so we wanted a u, in this case you would have to put a 2 here, because 2 times 8x gives you 16x. Excuse me, I'm throwing an x there too, because that would be 16x squared plus 7. Okay, so let me move this. This is probably better if I did it this way, up here. But I wanted to show you how I got the u value. And the u value is 8x squared, which is choice D. So they're not asking you to solve it or do anything like that. And then you just go about factoring u squared plus u plus 7, which you cannot do by factoring. Alright, question number 8. Find the solutions of x to the 4th minus 9x squared minus 400. Okay, so I recognize that it is a trinomial. There's 1, 2, 3 terms. And half of 4 is 2. And what I can do now is just use my Xbox method of factoring. Remember, this is A, B, and C. So A times C is negative 400. My B value is negative 9. We can list out all the factors of 400. And you'll realize that we have to kind of go more bigger numbers. About 8 times 50. How about about 20? That goes in 20. There's another strategy you can use. If I go to my graphing calculator and I just do 400 divided by x, show you what I'm doing. And then I'm just going to go to my table. And basically, if 400 divided by, say, x is 4, that gives me an answer of 100 there. So basically, I'm trying to find a number. There's 8 and 50, 10 and 10 times 40. Anything that's a decimal doesn't work. I like that one, 16 and 25. Let me see what they are. Yep, 16 and 25. Switch colors here. So 25 times 16 equals 400, but I need one of these to be negative, and I want the bigger number to be negative. And remember, this is splitting the middle term here. So this is essentially negative 25x squared and 16x squared. I'm going to put the x fourth and then the minus 400. We're just factoring. We've been doing this all year long, right? And greatest common factor in this direction is x squared. This direction is x squared. This direction is minus 25. And this direction, I'm going to assume, is 16. So I have x squared minus 25 and x squared plus 16. I'm going to set each of those equal to 0. And then solve. So add 25 to both sides. And remember, when you take your square root, you should have a plus or minus. So x is going to equal plus or minus 5, which just basically means 5 and negative 5. Same thing over here. Subtract the 16. Okay, pay attention. This is a negative 16 now, right? And then I'm going to take the square root. You're going to have a plus or minus. So x equals square root of negative 1 times the square root of 16. So the square root of negative 1 is I, and the square root of 16 is 4. So I have two solutions, right? That just basically means 4i, negative 4i, right? Those are the same thing. So we have 4 solutions there, 2 real and 2 complex. So 4, negative 4, negative 5, and 5. So B, C, E, and H are answers for that problem. Alright, let's go to the next one. Number 9, what are the factors? So this one you need to recognize that this is a difference of, or a sum of cubes. Why is it called a sum of cubes? Well, you could do something like this. The sum of cubes. And then we just need our SOAP. This is your A, this is your B. So A plus B, so same. Same. So this one is, let's do different color. Same, so that's a plus, then this is going to be a plus. O is the opposite of the plus, which is a minus. And then AP means always positive. And then all I have to do here is just put in the substitution. A is x. The b value is 3. A squared, so x squared. A times b, which is going to be 3x. And b is 3, so 3 squared is going to be 9. So then just pay attention to which one it is. SOAP. And that would be your answer. Question number 9 is B. Okay, use synthetic substitution to find this answer. Alright, synthetic substitution is basically synthetic division. So, pay attention, x is equal to negative 4. And then I'm going to take the coefficients, 1, 2, negative 7, 9. There's nothing missing there. And what I mean by that, there's no descending. Right, there's a 3, 2, 1, this x to 0. Just bring this one down, multiply, add down, multiply, add down, multiply, and then add down. So our remainder is just f of negative 4 equals 5. That basically means is you have a polynomial. Just put that one up there. That's 5. So if I draw a polynomial, this is at the third power, I might do something like this. So basically, at negative 4, then x is negative 4, because that's an ordered pair essentially, right? F of negative 4 equals 5. That's just negative 4 comma 5, and that's my ordered pair. Okay, question number 14. If x plus 4 is a factor, find the remaining factors of the polynomial. Okay, so it's telling us that it is a factor. That means the remainder is 0. Okay, this is certain. They're kind of telling us an answer. So I'm just going to use, okay, pay attention now. If this is a factor, I want to turn it into a 0 by setting it equal to 0. And therefore I get x equals negative 4. And I want that negative 4 so I can start my synthetic division. So 1, 8, negative 5, negative 84. And what I'm doing is I'm reducing the degree of the power by doing division. So bring it down. Multiply negative 4 times 1. Add down. Negative 4 times 4 is negative 16. Add down. Negative 21. And then this will give me positive 84. And we knew that the remainder was going to be 0. So this is the remainder. And then you can just work your way up. This is x to the 0, x to the first, x squared. So essentially this is x, pay attention, plus 4. And then this is now what I have left. And then the last part is, how do I do this one? I can just factor it. A times c is negative 21. My b value is 4. 7 and 3. That means this one would have to be, so this would be x plus 7, x minus 3. And hopefully you're getting good at that. Set it equals 0, you'll have x equals negative 4, negative 7, and 3 is my solutions. So, is x minus 7, pay attention, if you set that equal to 0, this is really x equals 7, and that's not the case, so not a factor. X minus 3 will return to x equals 3, and that is a factor. This one is x equals negative 7 because you subtract 7, and that one is a factor. And then subtract 3, x equals negative 3, that's not a factor, that one's a positive. Okay, a student was given the following problem. Use synthetic substitution to evaluate f of negative 3 when f of x equals that. Determine if the work on the right was done correctly. Okay, so this is f of x, right? And then basically the x value is negative 3. But if I were doing that problem, if x is equal to negative 3, that should go right here. X is equal to negative 3, and this one says what? A positive 3. So this is wrong. The answer is false. This goes back up to what we were doing before. So let's try to make this clear. This is a 0. When it says x equals negative 3, that is a 0, right? Where it crosses the x-axis, okay? Up here, you put that one in parentheses. Those are called factors, okay? So zeros versus factors, we learned about that. Big idea. Let's go on to the next one. All right, let's go over question number 17. This one tells us, what are the possible number of real positive zeros of the function p of x? Select all that apply. Well, here we can use Descartes' sign change rule. Shouldn't use dark blue. Well, you can always... Nice. Okay. So what that just basically means, if you want to test for positives, go ahead and sub in x equals like a positive x. And if you want to test for a negative, you're going to put in negative x. So all we have to do here is test the positive. Let's go ahead and do that. And you're going to recognize that basically everything just stays the same. And then here, it's basically the same thing. And then we're just going to count the sign changes because it comes back to the original equation. But I chose to specifically show you the parentheses because that's what you would have to do for the negatives. That's what I'm kind of making obvious. So if you simplify this, I'm not going to do all of them, but it basically goes what you have up here. Now, if this is a positive, we just have to count the sign changes. So that's a yes. From negative and negative, is sign change? No. This is a yes and a no. So here I have two yeses. So we made a chart before, positives, negatives, complex, or imaginaries, right? And this will equal the degree. So our degree here is 5. So I know it has to equal 5. And we had two sign changes. So that can either be 2 or 0. And if you look at that, I don't need to do the rest of the problem because we're just looking for positives. If you want to do negatives, then you would do that light blue step over here. Same thing, and then put in the possibilities. And then remember, complex only come in pairs. So for number 17, then our answer is just 2 and 0, which is C and A. Okay, question number 18. Consider f of x equals x to the fourth plus 29x squared plus 100. I said hint, use a graphing calculator. So let's go ahead and do that. That one didn't factor well. So go to y equals, clear. Then we're going to type in x to the fourth. That's my trick. Just type in x multiple times. And then is it 29 plus 29x squared plus 100. Just press graph. And you might need to manipulate your graph. Okay, so my graph's way up here. And here's the question. Does it cross the x-axis? Because that's what it says has so let's go ahead and put that in there. So what do we got? This one should say real zeros. And the answer for this one would be 0, because it doesn't cross the x-axis. Okay, so if I have, going back to the chart, back up there, so if I have 0 reals, remember reals can be both positive and negative from the last problem, right? But if I have a fourth degree, that means what's that number for complex? That means my complex has to be 4. So that would be C. And then do we have any repeated zeros? Okay, repeated zeros would just be if the graph bounced. So this was the kind of a really rough sketch of the graph. And we can't tell, but when I think of repeated zeros, I think of the ones that bounce off the x-axis. So in this case, the answer is 0. Alright, last question. Sketch the graph of the third degree polynomial function with x plus 2 and x minus 1 squared. I made this a true or false. And I said, did the student do it correctly? Okay, so what we're doing here is we're just graphing by multiplicity. Notice that this one is a odd. Uh-oh, what happened? Let's try that again. Okay, so if you solve this one, you get x equals negative 2. So that means the 0 is x equals negative 2. Its multiplicity is an odd. And think about it. This is how I always remember. You just draw a sketch. And what do you know about x to the first? Well, it shoots through. And then we do the same thing over here. Then there's two of them, but you could just do it once because you know x equals 1. So this is my chart. You guys see my chart here? And then, well, you have a degree is 2. And that is an even. So what do evens do? We'll draw out something you know. Easiest one, quadratic x squared. If it touches the x-axis, it'll bounce off of it. So we call that a kiss, evens kiss, or bounce. Something we also need to know about is the leading coefficient, LC. And you'll notice that the leading coefficient for this problem is positive. So it's positive, they start up and up. The leading coefficient for the linear problem, you'll notice what? Starts down, ends up. If I choose to put a negative in front of that, so negative x to the first, it just swings the other way. Starts from left to right, starts up, and goes down. Now if you look at this graph, it doesn't tell us anything about the leading coefficient, so it should actually start down and then end up. So this one was not drawn correctly, the answer is false. So if I actually wanted to do this one correctly, at x equals -2, we're going to have to shoot through, and then we're going to bounce at x equals 1. See this? So my pink one is correct. Pink, correct. And then the blue was wrong. Okay, what was their mistake? They did the zeros correctly, the box. They did the multiplicity correctly. What was wrong is the leading coefficient was incorrect. So hopefully this was helpful for you guys. We'll see you later. Bye.
Thou shalt do unto one side of an equation what thou doest to the other. Thou shalt not bear false witness against thy original problem. Thou shalt copy thy problems accurately and legibly. Thou shalt not covet thy neighbor's paper, nor anything that is thy neighbor's. I love math!